Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3071, minimum operations to write the letter Y on a grid. So you're given this n by n grid, which is just a matrix, and you know that the dimensions are odd. So, and basically what you're trying to do is trying to replace everything to make a Y. So a Y, and then every other cell has to be equal, but they both have to be different. And we want to find the minimum number of operations to do this, and meaning that each cell can only be a 0 or a 1 or a 2. So let's just go ahead and first try to find all the cells that are on Y and not on Y. So let's call this Y vowels and not Y vowels. And let's go ahead and get all those coordinates. So the Y vowels, notice that first of all, we care about the center. So let's call this center X and center Y is going to be, so let's call this M, and N is going to be the length of the grid and the length of grid 0. And those have to be divided by 2. So that's going to give you the center. So it's going to be M and N. And let's do it like this. Divided by 2 and divided by 2. Cool. So let's first do this branch. So let's say x, y is 0, 0, while x is less than or equal to center x, and y is less than or equal to center y. Then we're just going to walk down like this. 0, 0, 1, 1, 2, 2, right? So we're going to add that coordinate, and then we're going to increment x and increment y. Again, just going like this, right? Cool. And then we're going to do the same thing like this. So x and y are going to be 0, and then it's going to be length. So it's going to be, I believe, n minus 1, because this is going to be length. This is going to be length of 0, so the width of each column. And then again, while x in this case is less than or equal to center x, and y is bigger than or equal to center y, then this time we're just going to increment x, but also decrement y. And then let's go ahead and also add this to our set. I think it's in reverse order, so let's print this just to validate our work. So, okay, let's try this one. So 3, 1 is not correct, so it's still x, y. So 0, 0, 1, 1, 2, 2, so 1, 3, 0, 4, and then 2, 2 is not going to be included twice. Cool. So now let's go ahead and do this. So it's just going to be x of y is just going to be center x, center y. So we're just starting at the center. And then so in this case, while x is less than m, then we're just going to keep incrementing x and then leave y the same. So we're going to add x and y, and again, let's print this. Okay, just to make sure. So 2, 1 is not correct. Well, it is. So 1, 1, 2, 1. And then here, 2, 2, 3, 2, 4, 2, 3, 2, 4, 2. Perfect. So now that we have that, for the non-vowels, let's just go through the matrix. And again, if this is not in Y vowels, this is O of 1 because this is a set, then we can just add it to the other one, right? Cool. So those are the other coordinates, and then let's call this Y. Well, we should have called this the indices, but that's fine. Let's call this YY, and then not YY. And let's go ahead and get all the values. So for XY in Y vowels, YY.append grid XY. So while these are the coordinates, we're going to get the actual values for both in not Y vowels, NYY.append grid XY. Cool. So now that we have both values, we have to decide how are we going to change both of them. So we can either change this to a 1. And then here we can change these two. So 3 changes in total, which is going to be 3. In this case, again, we can change any number to 1, 2. So if we're looking at zeros, then the difference is going to be changing everything else to 0, right? If we're looking at ones, then we're going to have 5 numbers we have to change in the Y group, right? And we do the same thing here, right? If we're looking at zeros, then we're going to have to change every other element in here, however many this is, to a 0, right? And we just want to add both of those changes up and see what the minimum is. So since we're trying to minimize an answer, let's set the answer to infinity, and then let's create 2 dictionaries. And that's going to be for YY, so that we can count how many times each number appears in each list. So for A, B, in 1.items, let's call this, so basically if we're looking to change everything else to 0, then the difference is just the length of this minus B, right? And then this is the value itself. So let's call this 1 diff, A and 1 diff. And then let's do the same thing. And the 2 diff is just going to be, let's say we're trying to change everything else to 0, so it's just going to be the whole list minus the count of zeros. So length of NYY minus D in this case, right? So let's call this C and 2 diff. And then again, because when we're changing them, the ones on the y's cannot be equal to the ones outside of the y's. If A is not equal to C, then let's go ahead and print 1 diff and 2 diff. Okay, and you can see the smallest sum is 3. Perfect. So smallest sum is 12. So now we're just going to minimize how many changes it requires to make everything equal in both of the sections Y and not Y, and making sure all those values are not equal between Y and not Y. Okay, and at the end we can just return answer, but for example, let's go ahead and run this and submit it. So in this case, if everything is the same, so if answer is still infinity, then that just means we have to just replace everything in Y, because Y is always going to be smaller count than everything not Y, right? So then we're just going to return length of YY, right? That's just everything in Y. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.